must be carefully crafted, placed into the list in the proper sequence, debugged, and tested. While simple rules look easy to manage, most modern firewalls use much more complicated configurations with hundreds of rules. Some of these rules are actually links to other rules. When the organization expects more and more from their firewall, it's more efficient to create hyperlinked or jump rules, so when a specific situation is detected, it would trip a specific subset of rules. All of the related rules can be stored in a different list, speeding up the main rule base. Some of the best practices for firewall rule configuration are: the firewall device is never accessible or manageable directly from the public network. This is not to mean it's not connected, but that it can't be managed from the outside. It's a rule by itself to prohibit access to the firewall itself from outside the network. It's still possible to manage a firewall from outside the organization, but it usually requires the firewall administrator to VPN into the network in the organization and then access the firewall from an internal address. In fact, this is an excellent rule for all network management resources like IDPSs, log monitoring systems, etc. Deny direct external access and require VP access to internal connections instead. Simple Mail Transport Protocol, SMTP data, is allowed to pass through the firewall, but should be routed to a well-configured SMTP gateway, like a proxy server or email server. Allowing email traffic to go anywhere else other than to one of these devices is asking for trouble. Similarly, when web services are offered outside the firewall, HTTP traffic or HTTPS traffic should be handled by some sort of proxy access or ensuring that it is routed directly to the web server. Since a lot of attacks use web services, just like with the email server, it's best to make sure they're properly routed and, whenever possible, go through a proxy protecting the actual web or e-commerce server. In fact, any traffic that is not a response to an internal request for information or an external request for legitimate services the organization is offering should be dropped. All Internet Control Message Protocol data should be denied. ICMP is the protocol used to troubleshoot network and internet connections by network administrators. It's like picking up the phone to see if there's a dial tone. Unfortunately, it's also used by attackers as part of their scanning and sniffing tools. Disabling it on the firewall will minimize the types of attacks that can occur. Telnet, terminal emulation access software, to all internal servers from the public networks should be blocked. Managing a firewall is commonly done either from a set of keyboard, video, and mouse or KVM connections directly connected to the firewall hardware or remotely through a web or command line interface from the inside network. Allowing old-school telnet connections is problematic and can be exploited. As stated earlier, many organizations disable any internal access and require VPN access. But even internal telnet connections should be avoided. Most firewalls by default include a cleanup rule as their last rule, which basically states if there's not a previous rule that allows it, we're not. Some additional firewall configuration best practices include: any outbound packet must have a valid source and destination address. That means it must have a source address that is in your internal network and a destination address that is not on your internal network. Basically, any packet that enters or leaves your network must have a source or destination that falls within the range of addresses that are appropriate for that packet. The same restrictions apply to inbound packets. Any inbound packet must not have a source address that is in your network. Any inbound packet must also have a destination address that is in your network. You should also only allow outbound connections on HTTP, HTTPS, and SMTP designated ports unless users or system administrators can demonstrate a business need to access other protocols. In general, users and internal systems shouldn't have a need to access any services beyond these. These rules would be the only exception to the allow all internal out traffic rule. Some firewalls have no dedicated hardware. They are a virtual machine which run in a special operating system environment that allows multiple devices to run on a single hardware computer server. Under this model, the entire firewall's operating systems and software are packaged into a virtual machine that runs on any virtual environment as pure software. The administrator then maps it to the physical VM server, allowing it to use the external ports and connections. Using VM environment really adds flexibility to the organization in simplifying the operation and maintenance of a firewall, but it can make configuring it more difficult. A VM image can be backed up easily using a snapshot and can be easily started, paused, and stopped. If you make a change to a VM image that you regret, you can easily roll back that VM to a previous state. Firewalls are limited by the constraints of their configuration and capabilities. Firewalls are not creative and generally cannot make sense of human actions outside the range of their rules and programming. Firewalls deal strictly with the patterns of network traffic they review, which is known by attackers. At their heart, firewalls are computers and thus prone to the same errors, flaws, and their own vulnerabilities that other computers are. Firewalls are designed to function within the limits of their software and hardware and can only respond to patterns of events in a certain way. Firewalls are configured, built, and used by people, and thus subject to human error themselves. There are a number of administrative challenges to the operation of firewalls. First, training. Most managers think of a firewall as just another piece of technology, more or less similar to the other computers in the organization. They may assume any competent IT technician can configure and use them, but they're not. They're very complex pieces of equipment with their own language and function. It takes a substantial amount of training to properly set up and run a firewall. Uniqueness. Each brand of firewall is different, and no two vendor languages are the same. Each vendor makes their living on a particular firewall model, and the rules and operations of one vendor's model will look nothing like that of another, regardless of the similarities in the device itself. Responsibility. The firewall administrator may also be responsible for other aspects of network security, rather than just the operation and maintenance of the firewall itself. Administration. Ideally, a firewall would have one or more full-time technicians that do nothing but manage the firewall. In small or medium-sized organizations, running the firewall may just be one of many tasks an IT or security professional is expected to do. An administrator responsible for more than the firewall may end up with priorities that impact the management and maintenance of the firewall. In the next lecture, I'll discuss IDPS administration.